Hello. You should see the desktop now. Does that seem right? Does everything seem okay? Um, okay. Okay, let's see. I think everybody's almost here. Okay. Um, all right. So, first thing we do, let's see, we're going to talk about a new language, but first I wanted to finish language 6. We didn't look at the details of the interpreter for language 6. Remember, language 6 was the thing that created while loops and for loops. So let's look real quick at, and then we'll start talking about language 7. Okay. Let me clean this up a little bit. Okay. All right. So here's language 6. Remember, this language has if statements and while loops. Okay. Yeah. You can execute a while loop, something like here's an example of what it can do. In the REPL, I can create a parameter I0. Oops. There I0. Okay. So I have a variable 0, and I can say while less than I10. Okay. While I is less than 10, begin print I, and then plus I1 increment I, and okay. So while I is 10, begin print I plus 1. Oh, then I think another one of these. So close the plus, close the begin, and close the while. Okay. Whoops. What did I do wrong? I got an infinite loop, it looks like. Oh, I forgot that I added one. Well, no, let's see. What did I do wrong?
You aren't setting I to the value of the +1 every time. Is that what it is? Just at the plus I1. It's not like setting the new value to I.
Oh, I forgot to set I. Yeah, this is not, yeah. I forgot to set I. So let me do that over again. Okay, so I have to create a global variable I, there I0. Okay, then while I is less than 10, begin print I, and then set I to be equal to the I plus 1. Yeah, this kind of language is confusing. I mean, it is literally Lisp. You just have to kind of remind yourself how to write code in this language. So while I is less than 10, begin, print I, then set I to be I plus 1. Okay. Okay. Close the addition, close the set, close the begin, close the while. There. Okay. So yeah, there's the looping. It's hard to read because it's got all this debugging output, but there's the I incremented to 1, then there's I incremented to 2, there's I incremented to 3, 4, 5, 6, 7. Yeah, so you can see the I incremented. And then if you want to see this, just show you, if you open the interpreter code, and you turn the debugging off, you have to recompile it. Okay, so recompile it and run it. Now I'm running it without the debugging. Okay, now if I do the same thing, var I 0, okay, while less than I 1, begin, print I, and set I to be the sum of I with 1. Close the sum, close the set, close the begin, close the while. Oh, I forgot. I said while y is less than 1, while I is less than 10. See, there it prints 1 through 10. Okay. Okay. Now, oh, remember, the while loop always returns false. So this is the return value of the while loop. This is the side effect of the while loop. So while the while loop is looping, it's printing out it's printing out the I, but the value of the expression, our language, everything is an expression. So the value of the while loop is false, because the last thing it did was evaluate this thing, and it stops when this thing is false. So that's the last thing it did. It finally felt that it finally got that is finally became a false statement. Okay, so if you turn off the debugging, it looks more like a real programming language. So without the debugging, the language looks more. See, if I ask what I is 10 now. So I went up from 0 to 10. Okay, so and then I can set I to be 0. So now I is back to being 0. If I want to, I can run that loop again. Okay, and now I is back to being 10. Yeah, so if you turn off the debugging, it feels more like a real programming language. Though the debugging, I have that turned on by default because it for studying the language, for watching how the interpreter works, it helps. So when you run this REPL, the jar file has been built with the debugging turned on. So if you run the REPL this way, you see all the debug. So you see the environments being built up. So now if I say set I to 2, I see the I change in the environment, and the return value of set is 2. So the return value of the set is the right-hand side. So this was the effect it had on the environment. This was the return value, the value of the expression. Here, the effect that this had on the environment was to put something in the environment, and then it returned the right-hand side. I should come up with a better way to make these things look like return values. I've been trying to think of a good way to say this is the prompt for typing in responses. You have to realize that that's the return, that's the value of this expression here. Then the value of this expression here is this. I wish I could, if I could, it'd be nice to think of a good way to make it stand out a little bit more, as that the value of this is this. Okay, right? So if you type in an expression here, like we're just like var x being add, let's see, the add 5 to I. So the value of x is 5 more than I. Okay, right? Right. So that the effect it had was to put x in the environment. And then the value it returned was the value of this expression here, which was 7. Okay. Okay. All right. So this is kind of hard to read, but it gives you a lot of information. Okay, it's a little bit tricky to read, but it's showing you, it's making you think about what the language is doing. That these things had the side effect of changing the environment. Oh, let me do one more. Like if I type begin var x 100. Okay, what does that do? It created a local environment that was chained to the global environment, and it returned the value 100. But notice that now that global environment's gone. I mean, I'm sorry, that local environment is gone. That local environment only existed when this begin was executed. So like right now, if I say, if I look up X, oh, let's see. Oh, I already had I had an X in the local environment and I had an X in the global environment. So the X in the local environment was 100. So now if I check X, X is back to being 7. Yeah. So you can see that there was an X in the global environment, which had value 7. I temporarily created an X that had the value 100, but now that local environment's gone, so the X is back to being 7. Okay. Another example is if I do var A, there's no A now. See, undefined variable A, because A existed in that local environment, not in the global environment. So because I created a begin block, begin created the local environment, put A in the local environment, that environment was chained to the global environment. Another example, if I say var A, and then I say the sum of A with X, okay, that's going to create a local variable A, add A to X. Now, which X is that? That'll be the X in the global environment. Okay. So it created this A, it added A to that X and got 107, and A is gone. There's no more A. Okay. So it created a local environment, put something in the local environment, made use of the local environment, and then the local environment was dropped. So that's just a block. So it created a block, declared a variable in that block. In the case of in Java languages, we call these blocks, things that begin with a brace and end with a brace. That created a block, created a variable in the block, added something to the variable, or used the variable in the block to return a value, which was the variable A plus the variable X. That was this 107. And then the begin statement ended, and the local environment was deleted. So the local environment, notice how this is meant to show you as an arrow, so that when you look up something in the local environment, like X, if X, you don't find X in the local environment, you follow the arrow to the global environment. Here's a little bit more complicated thing I can do. Create a local environment inside of a local environment. So create another begin, and create a B variable. Oh, okay, var B equal to 1000. See, I'm right equals because I'm thinking of like Java. So var B 1000. Okay. So now I've created a begin a block inside of a block. Okay. In the new block, there's a variable B, and then I can add A plus B plus X, and then close that. Okay. So I've got this begin creates a local block, creates the variable A in that local block, then creates the variable B in another local block that's inside of that local block. And then it looks up the variable A, which will be in the outer block. Then it looks up B, which will be in the current block. And it looks up X, which will be in the global block. Okay. Notice that it created a chain of three environments. The environment holding B, which points at the environment holding A, which points at the global environment. Okay. And when you evaluated this expression here, you started in the local environment, don't find A here, but you find A here. Then you find B here. Then for X, you don't find X here, you don't find X here, but you find X over here. Okay. And then if you did X plus Y plus Z, okay, there's no Z. You create all these environments, and then when you look for Z, Z it'll be looked up. Well, there's the chain. Oh, why is there so many outputs? This begin created that chain, with the environment holding A chain to the global environment. Then this begin created that chain. So see, the interpreter shows you every step of what it's doing. So it created the outer block. That shows you, that's shown by this. Then it created the inner block and put something in it. So creating the outer block and putting something in it was that. Then creating the inner block and putting something in it is that. And then it used that chain to look up A, B, X, and Z. You know, A was found there, B was found there, X was found there, Z wasn't found, so you get the undefined variable Z error message. Okay, so the interpreter, the advantage of the verbose output is that you can see the things of the interpreter happening. And this is happening in, you know, if you run a Python interpreter, if you run a Java interpreter, these things are happening inside the interpreter. What we're learning is what's really going on inside any interpreter, but you don't see what's going on inside. The nice thing about writing our own interpreter is we can make it be as verbose as we want. We can watch it happen. Now, some real interpreters, like the JavaScript interpreter, you can turn on debugging information like this in them. Many of them have the ability to turn on real verbose output so you can see everything happening, but it's usually, in that case, more complex even than this. So this is a compromise. It's medium complexity. You can see what's happening in the interpreter if you study this a little bit, but it's not crazy. If you run a real interpreter like a JavaScript interpreter and turn on its internal debugging, usually the output is really complicated because it's actually there for the people who debug the interpreter. So it shows you stuff that maybe it's way more detailed than what we would want to see. Not all interpreters do have that feature, but some do. Some you could, if you know how to turn on switches, you can turn on switches, and then the debugger can show you a lot of stuff that's going on inside of itself. Okay, all right. Now, what about the code? How does and then there's the if statement. You know, we have this if 2 is equal to 1 plus 1. Okay. Okay, we know that's true. If 2 is equal to 1 plus 1, that's true. So print. Now I can only print, yeah, I'll print, say, 12, else print. The only data type we have is integers, so print 14. Okay. Okay. Now, why are there two outputs here? Okay. Well, see, that's why I need to come up with something that makes this a little bit easier to read. Why are there two lines out here? Why are there two lines? Why did I get two lines of output there? What did the for loop do? Or what did the if statement do? If, well, this is true, so it does what? Prints 12. That's this line. I asked it to print that. What's this line? Why is
The
that line
scope,
there?
the scope of that. Sorry.
Make a guess. Every expression has a return value.
Yeah, so
So
that's the
the if
return of the.
expression has a value. It's an expression. So whatever its value is, this or that. So now what's the value of a print statement? The value of a print statement is the value it prints. Okay, so I get the same thing printed twice. It prints its value and then print returns its value. So print prints its value, then it returns it. So for example, mean, here's an example of using that. Okay, if I say var t print 17, what's the value of t? Well, I'm setting t to the value of print 17. The value of print 17 is 17. So t is 17. So I'm going to get an environment with t in it with the value 17, but this thing, okay, now look, there's 3 outputs. This output here was the print 17's output. This was the environment being added with t. Then this var expression returns a value. It returns that value, which is 17 again. Okay, so this was the print. This was the side effect on the global environment. And this was the value of the expression. What I need to do is come up with a better way to show, like the fact that that's been printed by print, it would be nice to have a way of distinguishing that from this, which is printed by the REPL, which is telling you what the value of this expression is. So this output came from the REPL saying that every time you type an expression, it gives you the value. Like if I just type 44 here, it tells me the value of 44 is 44. Okay, but if I say print 44, then I get 44 twice because print printed it once, and then the REPL gave it to me once. Same thing's true in any REPL will be like this. There's the output from the print statements, and then there's the output from the REPL itself. If you play around with other REPLs, a lot of times they do this with different color coding. Like if you look in Dr. Java. System dot out print line 44. Did I type that right? Nope. Okay, so if I execute that, oh, no, oh, that's right. In Java, print line is not an expression. In Java, print is not an expression, so I don't get 2 outputs. I just get the side effect because print is not an expression in Java. So it does not return a value. Okay, so this is not an expression. So I don't get a return value from the expression. I only get the output, which is so this, notice the color here though. So if I type 44 here, what? See how the color is different? See, that is the REPL. That is print line, the different colors. So they distinguish the REPL giving you a value from the print line putting something out. So over here, when I type 44, I get 2 out. Well, if I do print 44, I get 2 outputs. One of them was from the print, which should have one color, and one of them is from the REPL, which should have a different color. Okay, like in
Professor,
JavaScript, let's see. Let's try it
could
in
you
Java.
move the REPL window up just a little smidgen, Professor Kraft?
Remember, I can bring up the JavaScript REPL by hitting the F12 key and going over here to console. Okay, so there's the JavaScript REPL. I can't remember if they put a print command in there. Print 5. I don't remember if there's a print. Well, there is. That's weird. print. Wow. The print function prints the current page. The print function in the REPL prints the current page. I never knew that. That's really odd. uh, uh, yeah, there. See, alert. Okay. Yeah. Notice how that, see, so now what, now notice that output, that's the value of alert. Alert returns the value undefined, and alert had the side effect of popping up a window that says 5. Okay, so there's two outputs. See, there's the output, the side effect of alert, and the value of alert. Now, to JavaScript's point of view, the return value of alert is the value called undefined. That's actually that's a value. This is bizarre in JavaScript. Undefined is a value. It's the value that says something is undefined, which doesn't make sense. If something's undefined, it doesn't have a value, but this thing has a value, but the value is the thing called undefined. It's, you know, they end up tripping all over themselves trying to make sense of this. So undefined, and you can even do weird things like 2 plus print 5. I'm sorry, not print, alert. Oh, now 2 plus print 5 was the value is not a number. The effect was to print the page, and the return value is this thing called not a number. Now, the reason it's not a number is because 2 is a number, but print gives you something, gives you undefined. Number plus undefined, you'd think it would be undefined, but no, they said it's not a number. So what? 2 plus alert 5. Okay, there's the effect of alert. The effect of alert is that output, and the result, the return value of 2 plus alert is not a number. And their reasoning is 2 plus undefined is not a number. It's still a numeric value. Not a number is a specific numeric value. If you look it up, not a number is a numeric value that says the thing isn't a valid number. Not a number exists in Java and C++. Not a number is part of the floating point number system. So NaN has been around forever. It's what you get when you divide by 0. Like 1 over 0 is not a number. It's something that returned by the arithmetic processor, but it's not a legitimate numeric value. So JavaScript is it's assuming that number plus undefined is not a number. I would have made it undefined again, but they chose to make it not a number. But notice that there's two things here: the effect and the return value. Here, when I say print 44, the first print is the effect, the second print is the return value. And I need to come up with a way to make those distinguish. Anybody has any suggestions? I'd be willing to hear, like, what would be an effective way here to say this one came out of the print and this one's the REPL returning something. Over here they do it with fonts. You can see like that's like slightly different shading and fonting. Like this is a different color, and this is a slightly different font. Actually, they also have this symbol. Actually, that's not maybe a good idea. Notice they used an inverted symbol here. That's what you type in. That may be a good idea. Use an inverted, use the less, that less than symbol. That's not bad. Yeah. Use the less than symbol. In fact, the nice thing about having your own programming language is you could try out an idea right away. So, like in your homework assignment, you have to dig into the evaluator. Okay, so dig into the evaluator to find out where it prints the return values. Okay, not print, but the return values. Okay, so now that would actually be in this file here. This is the REPL. Language 6 is the thing that builds the REPL. Okay, so let's look in language 6. Okay, language 6 can be run either as with a command line argument. If it's run with a command line argument, it loads a file. And if it's not run with a command line argument, it runs a prompt. Okay, so if there's no argument on the command line, okay. Oh, if there's too many arguments on the command line, it gives a usage message. If there's one argument on the command line, it loads it as a file. this is kind of a traditional way of doing things with REPLs. If you give the REPL a command line argument, it assumes it's a file name that it should run. Otherwise, it just runs the prompt. So we're interested in running we want to change the way the prompt works. So here's the thing that runs the files. So this one would run a file through the REPL, through the interpreter. And here's the thing that runs a prompt. Okay. Here's the read eval print loop. Notice it loops unconditionally forever. It's got a little counter to just keep track of how many times it's looped. It uses that for printing out these pictures. It creates pictures of what it's been doing. Oh, I deleted them. But it keeps a running count of the times it's looped so that it could use those in the pictures it puts out. So it's an infinite loop because there's nothing here to terminate it. Okay, here's the print of the prompt. Then it reads what you type at the prompt. Then it tries to execute it. Okay. Then here's where it evaluates it. Well, actually, what it does is after it reads what you typed in, it tokenizes it, builds an abstract syntax tree. Then it prints out debugging information. Then it evaluates it. Oh, right here. Now here's where it prints out the result. Okay, either it prints out a verbose output or it prints out a simple output. Okay, well, here, I would just type this. There's my funny prompt. There's my idea of what the JavaScript people are doing. I'll put an inverted prompt in front of the value. Okay, and I'll do that for both the verbose case and the simple case. Okay, so let's see how it works. Okay, so that's putting a little inverted prompt in front of the output from the REPL. Okay, compile it, run it. Okay, print 5. Ah, cool. That's the printer's output. That's the REPL's output. Okay, 8. The REPL, if I type in 8, the REPL gives me back out 8. If I type in plus 3 and 4, the result is 7. That's not so bad, is it? Okay, at least now there's something to distinguish. Let's see. Now do the for loop case. Okay, so var I 0, put. Oh, I'm in the simplified version of the REPL right now. Okay, so I'm in the one that's doing I forgot to change that. I've got the REPL with, see, the debug is 0. So I'm running the simplified version of the REPL right now. Okay, so set var I equal to 0, then, while less than I 10, begin, and then let's see, print I. Okay, then set I to be I plus 1. Okay, so close the plus, close the set, close the begin, close the while. Whoops. What did I do wrong? Did anybody notice what I did wrong? Oh, while 1 is less than 10. That's true forever. See, while 1 is less than 10. I thought I typed an I there. Well, while 1 is less than 10 is true forever. So see, the thing's going to loop forever. Notice I don't have a way to break the interpreter. I can only kill the interpreter. If this was a really fancy interpreter, I would have a way of breaking the interpreter without halting it. See, when I type Control C, now I just have to halt the interpreter. A fancy thing to do would be to write that interpreter so that you could break the interpreter loop, so that there would be some sort of something that would interrupt this loop, but keep it going. Something that would let you, like an exception or something that would let you halt, like not really break that loop. So there'd have to be some kind of, it would have to be something like in here. Here's the evaluate step. There would have to be something that would let you come out of the evaluate step with an exception that you could catch. Something that would let the evaluate, this is what was in the infinite loop. This thing here was in the infinite loop. So you need something that would let this function be halted without breaking the whole function. So some kind of exception. There would be some way of letting this thing return an exception without breaking the program, so that you could, so that the loop could just let you halt the infinite loop and then continue on. I'm not even sure how to do that in Java. I'm not even sure how that would be, how you might do something like that in Java. Okay. Now let's see if I go back over here. Oh, what I was trying to do is var I 0, then while less than I 10, begin print I, set I to be the sum of I with 1, close the sum, close the set, close the begin, close the while. I hope I did it right this time. There. All right. Then see, that one came from the REPL. The return value of while is false. These were the output of the print. Those were the side effects. Okay, so they were just printed. This was the print, and this is the value of the REPL. Well, that's kind of neat. That's not a bad idea. I think the job, that's not a bad little clever, that's a kind of a clever little thing to use an inverted prompt for the REPL's output. Okay. All right. Now, what I want to do is talk about how the while and the if are done in the interpreter. So go to the interpreter's output, the interpreter code, which is the evaluate class. This is the actual interpreter. Let's look at if. Okay. So look for the part that evaluates if statements. Okay. So here's evaluate expression. Here's, see, I kind of put them in order. Like I always put the thing that's new in the language at the front, so it's easier to find. Okay, so the new thing in the language in this case is if and while. And then this was in language 6. This stuff down here was in previous languages. So the thing that's the newest thing is I try to put that at the front of the code. Okay, so here under evaluate expression, there's, well, if the expression is an if, call evaluate if. Okay, if it's a while, call evaluate while. And then right after this would be evaluate if, and right after that is evaluate while. And I try to put the newest thing first in the code. Okay, so what does evaluate if do? Okay, first it checks that there's 3 branches. There should be a Boolean expression, what to do in the true case and what to do in the false case. If you don't have 3 branches under an if, that should have been caught by the parser. This is a good example of something that should have been caught by the parser. Okay, so this is a runtime check that should be a parse time check, but we're not using a sophisticated parser. And later I'll give you a homework exercise where I'll have you write a real parser for this language, which isn't that hard to do. But right now we're using we're using a trivial parser for this language. We're parsing tree languages, not this language here. So we're parsing anything that's a tree. So if you give F 17 branches, it'll parse because it'll be a tree where if has 17 branches. But so the parser will accept an if with 17 branches because it's still a tree. So we're parsing a tree language, but we really should be parsing, but I didn't want to write a parser for every single language. So as a shortcut, I wrote a tree parser. That's just a few lines of code. And then that parser works for every one of these languages because they all essentially are tree languages. But yeah, that should be a tree of exactly 3 branches. The parser doesn't care if it's got 17 branches, but we do. So we leave it up to the interpreter to check that there's really 3 branches. So the interpreter checks there's 3 branches. Okay, here's my return value. Okay, then I evaluate the branch 0. Okay, evaluate branch 0. I get back, that should be the Boolean part. How do I know it's a Boolean? I check its tag. Okay, so if you go over here, somebody could do the following. If, whoops, if 1, 2, 3. Okay, illegal Boolean expression because 1 is not a Boolean expression. So the interpreter got to the Boolean part, it evaluated to 1, and 1 is not a Boolean expression. Another example is if I did if, oops, if x, y, z. Now, undefined variable x was figured out by it wasn't figured out by this, it was figured out by this. When that tree was evaluated, x would not evaluate. So this undefined variable x actually didn't come from this runtime check. It came from a runtime check inside there. When the first tree was evaluated, the 0th branch was evaluated, it did not even evaluate. Okay. Now, if I do the following, something like var x 17, okay. Now, if I do this, okay, notice it's the same code if x, y, z, but now x evaluated properly. Here, x didn't even evaluate, so I got undefined variable x. Here, x evaluated, but it evaluated to a non-Boolean. So now that exception came from right here. This thing successfully evaluated. The return value had the tag of int, not the tag of bool. So the runtime check said, oh, you didn't give me a Boolean. On the other hand, if I do set x to be true, okay, now if I execute this, now I get undefined variable y. Notice that, okay, because x evaluated, it evaluated the true, so then I evaluated this guy. Oh, but then y is undefined. Okay, so that's the next piece of code. Okay, if this thing's a Boolean, okay, that's okay. So now you go here. If the Boolean value is true, evaluate branch 1. If the Boolean value is false, evaluate branch 2. Okay. And notice I have to always use the environment because these variables could be in the environment. Okay. So for example, now if I add y to the environment, var y 12, now I do this. Notice that x is defined true, y is defined 12, and z is undefined. So in a sense, there's something wrong with this, but evaluate's okay because it never got to the z. Okay. On the other hand, if I set x to be false, now evaluate this expression again. Now I'm back to undefined variable z. This was looked up in the environment. Notice I always have to look things up in the environment. So when I evaluated the branch 0, I evaluated it in the environment. Branch 0 happened to be x, which got looked up in the environment. Okay. X returned false. So the tag was Boolean. The value of the tag was false. So I jumped down to here and I evaluate the right branch in the environment, but the right branch wasn't defined in the environment. So Z was not defined in the environment. But on the other hand, if I put Z in the environment, there, Z 1000. Now evaluate this over again. See, now I get 1000. Because now when I got down here and I evaluated the right-hand branch in the environment, the Z got found in the environment. Okay. So notice that this same line of code could fail for all, it could succeed or fail, and it could even succeed when there's a mistake in it. When when X is true and Y is defined, but Z is not defined, it still succeeds, because it doesn't look at the Z. That's the difference between compiling and interpreting. A compiler would have maybe noticed that X was defined, Y is defined, and Z is not defined. A compiler can possibly might. It's actually a little bit tricky to sometimes figure these things out. But the compiler might notice that X is defined, Y is defined, and Z is not defined, and refuse to compile this, even though at runtime, if X is true, you don't need the Z. But the compiler would still say, but you shouldn't be doing this if you have an undefined variable Z. Now, this is how Python works. If you do this in Python, if X is defined and Y is defined and X is true, this will get evaluated. And this might even be undefined, but your Python program won't know it. Your Python program may not discover that you never defined Z until at some point you call this if statement with X false. And then all of a sudden, oops, you find out the Z wasn't even defined. That's the difference between interpreters and compilers. Interpreters tend not to find errors until runtime. And even at runtime, they don't find an error until you hit the branch of code that's got the error. When you evaluate this thing here, you don't find errors in this branch unless you hit that branch. If this thing is true, you only look at that branch, so you find errors in that branch, but you don't even pay attention to that branch. Interpreters can be very dangerous. No, you don't want your life depending on code that runs on an interpreter. And the truth is, no serious code anywhere in the planet is running in Python or JavaScript. All important code is running under a compiled language. There are compiled versions of Python and there are compiled versions of JavaScript. So if you want to write your serious code in Python, you could, but you do have to compile it because interpreters are too dangerous. You cannot rely on an interpreter. They don't know about errors, not all errors, but there's many errors that interpreters cannot find until they hit them. The interpreter just can't find the error until it hits it. Now, same thing is true of compilers. A logic error in your code, the compiler isn't going to discover it. If you've got a logic error, if you've got Z defined, but it's defined to be the wrong thing, the compiler is not going to know that. Okay, so logic errors aren't going to be found by a compiler either, but at least it's going to know that you have an undefined variable. So compilers will find a lot of errors that interpreters will not catch. Interpreters are considered way too dangerous. They're good for testing purposes and code like JavaScript and Python, but no serious programming that's safety, anything that would involve safety is never going to be done in an interpreted language. It's got to be done in a compiled language, and hopefully a good compiled language that can test for as many things as possible at compile time before things, find as many problems as possible at compile time. Okay, so notice that the if statement's real simple. Check there's 3 branches, evaluate the branch 0, check that it's really a Boolean, evaluate the Boolean, which means then you evaluate either branch 1 or branch 2. Okay, that's it. Result is either the result of the if expression is either the value of the left branch or the value of the right branch. See, so the result is either the value of this. Well, actually, this is the middle branch and this is the right branch. See, so the Boolean is the left branch, and then the return value is either the middle branch or the right branch. Okay. That's why result has to be declared up here null, because it's going to get set inside of this if statement. So you can't declare it inside the if statement. So you declare it up here. Oh, I can actually fix this code. I've been meaning to modernize this code. Let me show you how I modernize it. Notice that result is set only one time. It's either set there or it's set there. It's never reset. So now this setting it equal to null here is confusing. You know, that's implying that you want the null value in there. In the case is no, we never want that thing to be null. That's actually extremely misleading. So here's how you fix that. This is a real modern Java technique. You set that to, you do this. This is now called a, let me see if I remember the name. This is called a blank final. You can actually Google this. This is I only learned this like last year. It turns out to be, it's been around, it's been in Java for a while, and I think it's a beautiful idea. So you Google Java blank final. Okay, and there's this idea of blank finals in Java, and you can find a whole bunch of references about blank finals. Okay, now here's how you use it. It only works with values that are going to be set one time. So now this value can only be set once because it's final. It has no value at this point, and you can't use the variable, you can't return it. If you tried to return it, you would get an error here. Oh, wait a minute. Oh, this may not. Okay, now what we're going to do is here we set it one way, and here we set it another way. Okay, so this blank final is either going to be set here or it's going to be set here, but it's only going to be set one time. Okay, and then the return value is whichever one it got set. Now I'm trying to remember. This may not work. I think it will. It wouldn't work if you did this, because notice that it only here, if it's true, the thing gets set, but if it's false, it doesn't get set. And the compiler will notice that there's an asymmetry there. I think it's going to work here. Yeah, there. No, now what? If I delete the else clause there and I compile it, see, I got a compiler error. The compiler said you got a blank final here, so it has no value in it. If this is true, you put a value in it. But if this is false, there's still no value in it. So this thing may have no value, so that return value is not valid. Okay, and then here, error, variable might not have been initialized. So notice that the compiler is very clever about this. On the other hand, if you put back the else clause, now suppose, here's even more subtle. Suppose I delete that else. Notice that now, if this is true, I set result, but if this is false, I evaluate. There's an else clause, but it doesn't set result. Compiler is smart enough. Compiler says, well, you set result on the then part, but you didn't set it on the else part. Okay, the compiler figures that out. Okay, so these are called blank final. Now I have code that says, now by putting this as a blank final, I know that it needs to be initialized somewhere. I know, first of all, I know that there's no, now see, now it'll be, okay, now this is a mistake. Now this won't compile. Does anybody see what's not, this now will not compile. Does anybody see why?
Because it'll be set twice and you can't do that.
This won't compile. Saying that this thing was null is a mistake, and now it's actually literally a mistake. Why will this not compile? What's the meaning of final? Means that once you give it a value, you can't change it. I gave it the value null. What's wrong? I can't change it. See, if I give it the value null, I'm not allowed to change it. See, I cannot change a final value. So when you do a blank final, you have to leave it blank. And the beauty of that is that you're not somehow telling people that null is a legitimate value for that variable. This is implying something that's untrue. Null is not a legitimate value for that variable. That variable should never be null. This is way better. Now I'm telling someone this variable is going to be my return value, and I'll give it a value later on, but it needs to be given a value. And then here I see there's giving in. See, you can say here, this fills in the blank final. Fill in the blank. It's actually a clever name, blank finals, because now you fill in the blanks. Fill in the blank final. Now you fill it in one way there, and you fill it in another way there, but you fill in the blank final, and then you return it. Okay, now it's been. I've been meaning to go through. I kept forgetting to go make this change. There's a few other places where I can. This is a way of modernizing the JavaScript. This is a way of modernizing the Java and getting away from old-fashioned style Java programming to the new, more modern thing. Like they had to make the compiler smart enough for this stuff to work. You couldn't do this in really old versions of Java. I forgot when it was you could do. It's been a while. I just didn't learn this for a long time. Okay, so you know, doing something like this was a mistake. Originally it looked like that. The bad thing there is you're implying that that's a legitimate value for that variable. Right? And that's just not a legitimate value. Okay. Now you could do this. That's not a blank final. Okay. The trouble with doing that is that sometimes, let's see, that if you're not careful, you can end up with the similar kind of result that if you didn't give this thing a value, you got to make sure you do give it a value. But there's the difference here is that actually this still, if I get rid of that, it'll still not compile. See, the compiler said you didn't give this a value. You gave it a value here under one condition, but you didn't give it a value here in another condition. So actually, this is almost as good as the blank final. It's still basically saying that I have a result, and it needs to be filled in later, and the compiler will check that you really fill it in. Okay, so the compiler will check. So this is a blank. It's not a blank final. This is just a blank variable. Okay, so this is a blank variable. It doesn't have a value yet. The compiler makes sure you fill it in. Okay, so you don't really need it to be a blank final. It's still a blank variable. But in this case, I knew that variable is going to be set only one time. I knew it was going to be set once here or set in the other branch. Let's see. Okay. Again, same here. If I delete that, this won't compile because that's blank. It's set under true here, but it's not set under the false here. So this thing might still be blank, and it won't let you use it if it still might be blank. Okay, right? So blank variables are better. That's still better than doing the equals null here. Oh, notice that shows you a thing that they teach freshman programmers, that you should always initialize your variables. That's not true anymore. But an important thing to realize is that a lot of what you're taught in programming classes is wrong by modern standards. It's not true to teach people to always initialize their variables. This variable is better left blank, either as a blank variable or as a blank final. It's better off left blank, and then let the compiler make sure that I really fill in the blank. If I okay, now see if I go back. Look what's wrong with this. Suppose I do this. I follow the old advice. I initialize my variable. I accidentally forget the word result here. Compile's fine. But now it might be returning null, which is a big mistake. See, now I might be returning null. I've got a screwed up program here, and the compiler didn't help me because I initialized the variable. That's a mistake in this case. By initializing the variable, I lost the ability of the compiler to help me. This is an important lesson. Everything you were taught about programming, you have to unlearn and relearn and find out what's really the right way to do everything. certain variables should not be initialized. It's the idea that you should initialize all variables came out of languages like C. Okay, C is a really lousy language. Nobody should be taught. Nobody should use C to teach people programming, because there was an old saying among there was a guy named Jystra, who's a real famous computer scientist. He's dead now, but he was famous in the 70s and 80s, and he said that certain programming languages damaged your brain. And his feeling was that there were languages out there that did brain damage to you. And if you learned them first, your brain was permanently damaged. Like C, because C would teach you things like initialize all your variables, which in this language C is a good idea. You should initialize all your C variables. But modern languages like Java, those rules are wrong. Java, you should not initialize all your variables in Java. Java actually will initialize the ones that need to be initialized, and then certain variables shouldn't be initialized, because now the compiler will find mistakes for you. The compiler notices that you didn't do the right thing here. And in fact, in this case, I'm even better off making that a final blank variable, because I'm never really going to change it. And now the compiler helps me. By not initializing it, the compiler can do me a benefit. Okay, so that's the way this one. That's the way. And there's a bunch of other places. I should go through and modernize. If I had, would I have time? I wanted to go through, and there's a few other places I know where I can do little things like that, where I can modernize the Java by making better use of blank variables, rather than using initialized variables. There's several, like actually it's every place here where the result is set to null. Again, there shouldn't be the null there. And and this one probably also should be a final. This one probably also should be a blank final. Okay, now this is the while loop. Okay. Yeah. This one also can be a blank final. Okay, because the values can only be set one time. Okay. In fact, in this case, this variable doesn't even need to be there, because while loop always returns false. So if I really wanted to, I could just make this thing return a new false value. So I actually don't even, in the case of the while loop, if I actually wanted to simplify things a little bit, I don't even need that variable there. I don't know, maybe I should write it that way. Okay, always return false. So just return a false value. So I don't need a return variable in this case. Okay, now what does a while loop do? So actually, this would be the slightly improved version here. I don't even need that variable for the while loop. Okay, the while loop needs to check if there's two branches. If there's two branches, okay, then evaluate branch 0. Branch 0 should be a conditional, should be a Boolean. So check that it's a bool tag. If it's not a bool tag, you got a problem. So, over here, if I say while 1, 0, I get illegal Boolean expression. Well, there's the Boolean expression that's illegal. Okay, so that doesn't interpret, because that shouldn't be that should come back as a Boolean. And similarly, if I do something like while apple 1, I get, now notice that was not gonna, this case, it tried to evaluate that, and the evaluation of it failed because it looked up apple and didn't get a value. So this was not that it's an illegal Boolean. This is the evaluation of this guy failed because apple couldn't be looked up. Okay, so you evaluate the conditional, and if it doesn't evaluate, the evaluator, this is recursively evaluating it. Where is it? Okay, you evaluate the Boolean recursively. If it doesn't evaluate, this guy throws an exception. Okay. Okay, and if it does evaluate properly, then you check that it actually returned a Boolean. If it's true, you drop into a Java while loop. Notice I'm going to use a Java while loop to implement my language's while loop. Okay, this is where I can cheat. If I was writing a compiler, I would have to generate all the code it takes to create a while loop in machine code. Since I'm using Java as my language to write the interpreter in, the while loop that I'm of my target language can be implemented using a while loop of the Java language. That's considered a legitimate way to cheat. Okay, my host language can be the thing that implements the target language. We call this the target language, and we call this the host language. And here I have a one-to-one mapping between what I want the target language to do and what the host language can do. So the host language's while loop checks the value of the conditional. Okay, if it's true, it enters the while loop. Okay, now what it does is it evaluates the right branch. It does the body of the while loop. Notice it does not keep the return value. It's checking it for its side effect. So it evaluates the body of the while loop, reevaluates the Boolean expression, makes sure it really is a Boolean expression, and if it is a legitimate Boolean expression, lets Java check if it's true or not. If Java says it's true value, then it's going to reevaluate the body of the while loop, reevaluate the Boolean, make sure it still is a Boolean. Notice that this check is being done over and over again, but if this thing's a Boolean one time, it's going to be a Boolean every time. I might be able to, okay, here it got checked once, but the truth is our language could be really weird. For example, this could be a function call. Later on, we'll see this could be a function call that returns a Boolean most of the time, but returns, say, 0 sometimes. So I actually can't just say that if I checked it and it's a Boolean once, I never need to check that it's a Boolean again. Because when the language grows, it'll turn out that this part here could be a function call. And the function, since that's an untyped language, the function might sometimes return Boolean and sometimes return integer. So I have to keep checking that the return of the middle part is a Boolean. So every time I check the Boolean branch, I have to check that it really is a Boolean. See, every time I evaluate the Boolean branch 0, every time I check it, I have to check that it really is a Boolean value because it's an interpreted language. This is one of the problems with interpreted languages. And it's also a problem of a combination of an interpreted language and a language that doesn't have strong typing. So even if this is a function, in a strongly typed language, that function would have to return a Boolean value. So if I knew that function returned a Boolean value, I wouldn't need to check it over and over again. But in a not strongly typed language like ours, a function can return a Boolean sometimes and return an integer sometimes and return a string sometimes. That's the way Python functions are. Any given Python function you call it one time and it returns a string, and you call it another time and it returns an int, and you call it another time and it returns a Boolean. The function can return anything it feels like. So you don't have just because it returned a Boolean once doesn't mean you have to return a Boolean again. A compiled, strongly typed language would look and see, oh, that is a Boolean expression. So then the compiler can guarantee that that's a Boolean expression, and you don't need to keep checking over and over and over again that you got back a Boolean tag. Okay, so again, we're seeing what's wrong with languages like Python and JavaScript that are neither compiled nor strongly typed. You have to do this in Python. Python, when it's running a while loop, one of the reasons Python's slow is every time it evaluates the Boolean part of the while loop, it's got to actually check that it got a Boolean value. That little check has got to be in every step of a while loop. Slows you down. That's why Python will never even be a fraction of the speed of a language like Java or C++, because the Python interpreter is going to have to always make these little checks. It can never assume that this branch is going to give it back a Boolean. It just cannot make that assumption. Even if it gave it a Boolean 1,000 times in a row, the next time you call it, it might evaluate to an integer. Okay. All right. So every time if we got a Boolean though, then we let Java evaluate the Boolean to tell us whether the loop we should continue looping or not. When we're done looping, we return false. Okay, so we return false when we're done looping. Okay, and here's an example where I can make that thing a final variable. Like here, this is evaluate set. This one should be final this should be a blank final. Now we look through here and we see that result, it's set there. That's the only place where it's set. Okay. That's the only place where it's set. And so in fact, I even could have just moved this declaration to that line there. Since set only sets the return value in one place, I even could, if I wanted to, I'm not sure if this makes it easier to read or not, but I could just put the declaration right there. Okay, because it's only, this case, it's only set one time. Okay, so compile, see, that's perfectly okay. I'm kind of burying the return value, but it's only going to be set in one place in that case. So I don't even need to, I don't need to use a blank final. I can just say final result. Now result's never going to be changed. It's going to be set one time. So I can say it's fine. If I delete the word final, then I'm not telegraphing to people that this thing's never going to be changed. By leaving the final in there, I'm telling anybody who reads this code, you don't have to look for this variable anymore. Once it gets a value, it never changes. So since I know that's the case, I should declare it final. So that's one of the things I could do to modernize my code a little bit. Okay, like here's another one. This could be a final, and it should be blank. Now this one I think is just like set. It's only going to be set in one place here. So this one, I could improve the code a little bit by actually just moving that one right there. Final value result. You know, yeah, it's only set in one place. See? Okay. So, and I should say it's final because once it's set, it's never going to be updated again. Okay. And I can go through with some of these. Now, some of them aren't some of them, the result value could be updated like in a loop. So like this one, it's only set once. Okay, so this one could be final value result, and I can get rid of this one even. I'm not sure if that makes it better. You know, on the one hand, it's sometimes some people like seeing that the return value is declared right at the beginning. So there's my return value. It's a mistake to set it equal to null. It definitely should not be set null. It should either be declared final here, or it should just be declared where it's going to be set. Okay. I think programmers kind of argue a little bit about this one. You know, there, you know, it's only set one time. So here I'm setting it in the one place where it's set, and I'm declaring that it's a final variable so that anyone reading this code knows that thing's never going to change. So once it's got its value, I don't have to ask what else is going to happen to this guy. Okay. In fact, notice that it goes from this line of code to this line of code. I could even get rid of the variable. Again, I don't, you know, it's questionable whether that's a good programming step or not. I could do that. To me, that's a little bit obscure. You know, I'm returning the valuation of that expression. Yeah, I don't know. I probably wouldn't want to write it that way. Though some people might say that, you know, you only set it one time and it was set to that value and that's what you returned. I kind of like it better like this. You know, that's my return value, and now I'm going to return it. Programmers can argue about some of these details, like what is the best style. What's not a good style is the way I had it before. That's not good. That's signaling two things that are wrong. It's signaling that null is a legitimate value for this variable, and it's signaling that this variable can be set more than once. So I'm signaling two things here that, you know, when I read that line of code, as far as I'm concerned, null is a legitimate value, and this is a true variable because it's not final, so it could be set more than once. Okay, both of those things are wrong. So at the very least, it should be declared final, and it should be left blank because null is not a legitimate value. Okay, but I think in this case, it's probably not a bad idea to just go ahead and leave it out there and just declare it where it's, you know, there's the final There's the return value. And you can go through and fix this in other places too. Like here, that's a final variable. Okay, so that was set there, and it was never modified, and then it's returned. So that should have been declared final because it was set, never modified, then returned. So should clear up the fact. Oh, the compiler, the compiler makes use of the fact that you declare these things final. So the compiler can do more optimizations. You're actually even helping the compiler. When you declare these things as final, you're actually also helping people. You're helping people who read your code, and you're also helping the compiler. The compiler can make use of optimizations that now that it's been guaranteed that that variable never changes, the compiler can make some optimizations that it might not otherwise be able to make. Okay, I've read that in the Java language that's not as helpful as it is in some other languages like C and C++. That supposedly that this doesn't help the Java compiler as much as it does the C and C++ compiler, but people still say it's a good idea. It's still helping, it's still signaling to the compiler that that thing never changes, so it can make some optimizations. But there's questions about whether Java language can make use of that information as well as some other languages can. So all through here, I can go through and I could make better uses of some of these variables. Okay, so run out of time. Okay. So now we've seen how exactly how the while loop and the if statement work. Actually made a little improvement on the REPL. The REPL now looks better. You know, it's got this little improvement for the output of the REPL, copying that from the JavaScript REPL in the browser. I wonder if Firefox does that. I don't know if that trick in the if that was a trick that Chrome had. Yeah, I don't know if that was just strictly a Chrome Yeah, I don't know if that's a Chrome trick or if that's a trick. I don't remember other interpreters doing this little trick. I think it's cute. It's clever. You know, invert the prompt. I don't know if that's Chrome invented that or if Netscape does or if JavaScript can. You know, and I'm not sure whose idea that was, but I think it's a clever one. Okay. So we've seen how we finished language 6, and then next week we'll launch into language 7 with function calls. And there'll be a new programming assignment where you modify language 6. Okay, so there'll be a programming assignment up there pretty soon where you're going to add, just like you added some things to language, I forget which one it was, language 3, you're going to now add some things to language 6. You're going to add, what was it? A for loop and a repeat loop. So you'll add a for loop and a repeat loop to this language here. Okay. Okay. If you have questions, come to office hours or send me an email. And let's see. So have a nice weekend. And next week we'll work on the new language, language 7, which is really the whole goal of the class. Functions are where things are. That's what we're really getting at. Languages with functions are what are really interesting. So that's where the meat of stuff will be. Okay. Anybody have any question? Any last question? Any last question at all? Okay. So I'll stop sharing and we'll meet again on Monday. Have a nice weekend. Bye.